Welcome and thank you so much for joining me today. So we are going to be looking at a traversable graph. This means that it is a trail that includes every edge. So this could be a trail, it could also be a circuit or a cycle, but as long as it is including every single edge. So for example, let's look at our first one. We can go from A all the way to C. We can then go from C all the way to A back up to B, and B going to C. And we haven't gone over the same edge. So we haven't repeated any edges. So this is a traversable graph. Now our next one is a non-traversable. And that is because we can't go over a same x. So if we're just trying to work it out, I can go from A to C, C to D, D to B, B to A, and A to D. And I've missed one. And no matter how many times I try, I'm always going to miss one side. So I can come up with some rules here. So the first thing I want us to do is think about both of these. So if I'm looking at all my degrees here, A has got 1, 2, 3 degrees. C has got 1, 2, 3 degrees, and B has got 2. If I look over at this graph, A has got 3 degrees, B has got 3 degrees, C has got 3, and D has 3. Now, the more we do and trial this, we are going to work out two rules. They must be a connected graph, because otherwise we can't have a trail. And all the vertices are even, have an even degree, or exactly 2 vertices, which we found over here, have a odd degree. So we're going to use that rule, and on top of doing it, we're going to do trial and error and see if we are able to determine if these are a traversable and state why. So the first question here, I'm just going to look at how many degrees each of my vertices have. So this vertex here has 3 degrees. This vertex here has 3 degrees, and all my vertices has 3. So without even trying, I can state that it is a non-traversable graph, and that is due to having more than 2 vertices with odd degrees. So that is what we are able to work out. Let's go to our second one. We can see straight away that every single vertice, it has an even degree, which means it has to be a traversable. So it is a traversable graph, as I can create a trail. All vertices are even. And let's double check that when we are doing it. I can go from one vertex to the next, then I'll just keep on going around, and it is a circuit. Okay, let's move on now and look at the third. This third here again, I'm just going to look at the amount of degrees I have. So here I've got 3 degrees, 2 degrees, and 3 degrees. Now, one of the rules that we stated was it is traversable, providing it has only 2 odd degrees. So as it has 2 odd degrees and the other vertices are even. So because of that, we are able to now form our trail. So my trail, I'm just going to be going from this vertice, this, going around the loop and going to all my vertices. Let's move on to a few questions. Again, have a go with these yourself. I always think about the rules to help me out. So every single time I list the amount of degrees I have. In this case, I've got 2. I've got 2. I've got 4, 2, and 2. So I know question 4 will be a traversable graph. So it is traversable. And I will double check that by checking, because remember, a traversable graph, I should be able to go to over every single edge. Let's look at question 5. So question 5 again, if I look at the amount of degrees, I've got 1, 2, 4, 1, 2, 2. So again, every single vertice has a even amount of degrees except for 2 that is odd, which fits our rule that we've worked out in terms of if we are able to go over every single edge in our trail. Okay. So we've made our circuit. Let's look at our last one over here, 6. So with our 6, let's look at our degrees. So my degrees here is 1. I've got 4, 3, 2, 3, and 3. Straight away, I know it is non-traversable. And I am able to double check that by trying to draw a path. Because I'm going to start off over here. Now, I'm here, and I need to somehow go to over all edges, but I'm always going to miss one. I can go back, and I can try again, but I'm still going to miss one of my edges. So I know it is a non-traversable graph.